Alright, so here's the more of an advanced circuit number 2 that we have, that could be given to you as a question. And again, the idea is to be able to construct a truth table, okay, which basically lists out all the possible inputs which are already provided to you in the question, and write down all the outputs for each of those inputs. Okay, now for this kind of circuit it might be slightly more difficult, so let's just follow the process. Remember that the very first step was to simply mark out all the outputs of each of the gates over here using letters which are not already used. So I won't use A, B, C or X, but let's say I write down D over here, E over here, F over here, and then the final one is already uh, labeled X. Okay, so I will write down those outputs over here, D, E and F. Okay, now again we will do the same thing, which is to focus on one gate at a time. The first gate that we have starting from the left side is this gate over here, which is, as you can see, that's the OR gate, and the input it's getting is A and B, right? And it's the OR gate, so let's just produce all of the outputs for this. Remember, in OR gate it gives out a 1 even if one of the input is 1, right? So over here it's going to be 1 1. I'm just focusing on what the input A and B is. Okay, again 1 1 1 1. For the last two, both of them are 0, so because none of them is 1, I'll just give out a 0 over here. Okay, so that's our answer for the first gate, which is giving us the output D. Now we will focus on the next gate, which is E, right? Now for this gate, if you look at it, it's taking one of its input from D and it's taking the other one of its input from C. Okay, so the two inputs we will focus now on is basically C, which is going into this gate, and D, which is also going into this gate. Okay, let me draw up a line just to demarcate which signal, which values belong to which signal, which column. Alright, so we will focus on C and D only, and again, if you recognize this gate, this is again an OR gate, right? So 1 1 gives out a 1, 0 1 gives out a 1, 1 1 gives out a 1, again 1 1 1, again 1, and only in the final one do we get both inputs as 0, so that will give out a 0. Alright, so that's our answer for this gate. Alright, so we have evaluated E. Now we will move on to the next gate, which is F. Okay, again let's focus on what inputs it has, right? The gate is, of course, this gate is the AND gate. The inputs it's getting is the one of its input is coming from A, right? The other one of its input is coming from E. So we will highlight both those columns, A and E, right? So A and E over here. Again, let me first draw up a line over here, right? So again we will focus on A and E, and remember the gate is AND, right? What was the logic of AND? It produces 1 only when both the inputs are 1, right? So for the first input it's 1 and 1, that produces a 1. For the second input it's again 1 and 1, that also produces a 1. Same for the next input, 1 and 1, that produces 1. Again 1 and 1, that produces 1. But for the next set of inputs we have 0 and 1, 0 and 1, 0 and 1, 0 and 0, which, if you follow the logic of AND gate, produces 0 all the time. Okay, if you are unclear about this, please go back to the basics of logic gates, introduction to logic gates, and look at what inputs AND gate produces for each of its for what outputs does AND gate produces for each of its inputs. All right, now it's time for the last gate, which is the XOR gate, right? Now the XOR gate over here, let's look at what input it's getting. It's getting the F and it's getting the input from C. Okay, so F and C is going to be our focus. F and C. And what gate is that? Can you identify which gate is it? It's the XOR gate or XOR gate or XOR gate. Okay. So the XOR gate, what it does, if you again recall the logic, is it gives out a 1 when both inputs are different. If they are same, it gives out a 0. Okay. So if you look at the first two inputs, it's 1 1, it's the same input, so it's 0. The second set of inputs is different, so it will produce a 1. The next set of inputs is again same, it will produce 0 again, this time 1, then 0 again, because again it's different because it's 1 and 0, so that's 1. 0 and 0, that's again the same input, right? So we are going to get a 0 over here. 1 0 produces 1 and 0 0 produces 0. Hence we have successfully been able to produce the exact truth table for this circuit as well. Okay, so that was our second example. This is the more difficult example. If you are new to logic gates, I would advise rewatching this video for further clarity.